I think we can start. So hello everyone. My name is Piotr Śliwa. I'm a lead developer at 7N, who is sponsoring the Java path on this conference. Who you can find our kiosk in the chillout room next door. I'm also doing my PhD at Wrocław University of Economics, where we with the team study startup to find out what are the rules, what makes them work in the way they work, and we strive to find the holy grail, so-called. So it is a set of features, a set of methods that would enable a repetitive possibility to create a successful startup. So let me start with a question for you. How many of you had or have a side project that you code after work? Okay, that's cool. And how many of you hit 100 users with the project, or 100 downloads or GitHub stars? Cool, nice. And 1,000 maybe? Oh really? That's nice, that's cool. I might want to talk to you after the presentation. Okay, so the thing is, let me tell you my story. Back in 2012, I was really bored with my Facebook feed, which was overwhelmed with the posts from the users that I had the least common interests with. So I got a lot of posts with kittens, with puppies and stuff like this, with just mildly interesting shower thoughts of my friends, and I decided to create some social platform that would match people based on their interest and not because of they clicked a certain button. So the goal was to create a social platform that would match the users based on their browsing history. I know that it might seem creepy right now, but it was the idea back then. And I talked with my friends who seemed at least as enthusiastic as I was of the idea. So one day I decided I would do it. And I started coding. I coded really hard, even during the holidays when I was in the Netherlands picking up broccolis. I picked them up during the day and coded during the night. So it was like very strange farmer during the day, nerd during the night situation. But anyway, I coded really hard, and after nearly a year, I decided to release the product to the public. I told everyone in my dormitory that I would do it. I posted it to Vcop, to Reddit, and pressed the button. Fell asleep thinking about scalability, about if my laptop will handle all the users that were about to come. And as it turned out, the next morning, to my horror, when I opened the laptop, there was the number of 4 new users, including me being one of them. So for me it was devastating. I didn't know what caused it, because for my knowledge the product was perfect. It had the almost 100% code testing coverage. It had really great frameworks underneath. So for me it was perfect. But somehow the users didn't like it. They didn't care about its existence. So the thing is that the example, as possibly many of you, this is not a lone example, because according to statistics, according to CB Insights, which studied around 1,000 startup companies, around 70% of them, of companies, which are not side projects, but they are real business entities, fail during the first 20 months. So the number is really great when you think about it. It's huge, because if we created 4 companies, 4 startups right now, right here on this room, 3 of them would be dead statistically within the next 2 years. So it isn't really optimistic, is it? And so does it have to be like this? Is there any way to do it better, to make sure that if you have an idea and you work on it, you make it to the success? And the answer to this question lays in the waste of time, money and energy that we invest in things that market doesn't want. And in this presentation, I would like to show you, to introduce you to the concept of lean startup methodology, which is basically some kind of TDD, test-driven development for creating a startup. So I want to show you that when we create startups, we should take the scientific approach instead of following the heart, which is not always the best way to do. So, but first let me introduce you to the concept of startup. So startup is a venture that is characterized by very high level of uncertainty. And by the uncertainty, we mean all the assumptions that you do during the creation, during ideation, during creation of the idea. Because if you have an idea and you create it based on your inner knowledge or your inner sense, so you think that users need something, or you think that this particular feature solves the problem, you make some kind of assumption that is not either true or false until you test it, until you prove it wrong or right. And a venture can basically mean anything. It's not only a business entity, it's only a part of the venture category. It can be an open source project, it can be a new game you create, it can be a new internal corporate project. So if you create a tool for example, intranet tool for your company, you also have some kind of a startup, of a venture. So every venture starts with the market. There are users who have certain problems, certain needs, and you create the venture to build a product that would solve their issues, that solve their problems. And by solving the problems, you deliver them value, you generate value for them. So when we go back to the statistics, that 70% of the tech startup companies fail during the first 20 months. If we get deeper to the statistics, it turns out that around 42% of them failed due to lack of the market need. And the lack of the market need means that one of the assumptions, either that a product that you create solves certain problems of the users, or that the users have the problems, is wrong. So if either one of the two hypotheses is wrong, then there is a lack of the market need. So how does it typically look like? A developer wakes up with a cool idea, he defines a set of features and starts to implement it. The time goes by, the invested time in the project also goes by, and finally, when the release date is on, the statistics, the probability come into play. Because you can either be true and the hypotheses you have are true and the market really needs your product, which is cool, which is great, and as the statistics show, this is far more common situation. Your hypothesis, one of the hypotheses is wrong, and actually what you got is no interest from the market in your product. And to solve this problem, in Silicon Valley, Steve Blank developed a model called Lean Startup. It was created by Steve Blank and then popularized by Eric Ries. And it was proved, it was tested on multiple startups. I read that it was something around 2,000 already. So it proves that it works really well. And it basically, as I told you, is a test-driven development or behavior-driven development framework for creating startups, for real life. And the Lean Startup defines something that is called minimum viable product. If we use the analogy of test-driven development, then minimum viable product would be some kind of a mock object for for startups. So basically we create something that mimics the real product, we push it to the market, we throw it to customers and see what happens and see if they really need it. So MVP, a minimum valuable product, should have only a minimum set of features. And it's not like it should have, but it has to have. When you create a test, when you TDD, you don't want to include more features in the test that you really need to test, right? Because every new feature, every new functionality can affect your outcome, can make the test be false positive or false negative. And the same situation goes with your minimum viable product. Because if you create a full-blown product with all the features that you first thought of, so for instance, you are creating a web-based application with user support, with cool user experience, with everything, and you push it to the market, and the market proves it to be good, so it really likes it. You don't really know which feature does it like. You would have to investigate it further. It doesn't really matter for this particular instance. So with MVP in the lean startup, the bottom line is that you create the MVP and you slim it down as much as possible. You do it in the most cheap way possible, and you push it to the market, you release it, and observe what happens. So in the negative scenario, when the minimum viable product proves your hypothesis to be wrong, the market doesn't need your product, or it doesn't necessarily solve the problems in the way that the market need, then you do something that is called pivoting. You either throw it away or you modify it in the way you think should work, and you try again. And the thing is that you don't have to be too attached to your idea. It's like a roulette. It's not possible for you as a human being to know exactly what all the market needs. You can try to do it, but you always have to check the outcome if the reality is really as you think it is. And there are a number of examples of great big companies and billion-dollar companies that pivoted during their first year of living. So one of them is of course Groupon, who pivoted from being a social advocacy platform, or Instagram, who first was a microblogging platform and then pivoted from there to being just a picture sharing website. So the other scenario is that your minimum viable product proves your hypothesis to be right. So the market needs this solution, and the solution is right, does the good thing for the market. And your product gets downloaded, it has more features, more users. Then you do the action called perseverance. So you persevere on the path and you go into this particular direction. And then you can either rewrite your MVP, because for sure when you prototype it will have some kind of bad design practices and shortcuts and everything like this. So probably you would have to first refactor it a little bit, and then you try to implement more and more features. And the features follows the same rule as the MVP. Every new feature is an MVP itself. So you have to create the feature and release it and observe what happens. Here you can see that on the vertical line we have the download per day ratio. On the horizontal one we have the time. And let's say we release the feature number 1 here. As you can see, the market doesn't really care about the feature. We cannot say if the feature really impacted the download rate. It could be also worse, because it could cause the line to go down, which would obviously mean that we have to revert it. Right here we probably want to revert it because we don't really need a complexity in your code that doesn't really matter. So we pivot from here as for MVP. The other scenario is that we release the feature, and the feature proves itself to be wanted by the market, and then we persevere as with MVP. Okay, so that's all in terms of the theory. Let's get to more practical examples. Let's say we studied dietetics, and we came up with an idea to create a diet finder, some kind of a system that would give you your personalized diet recipes instantly without going to a dietitian and without leaving your home. So the first stage would be to achieve something called problem-solution fit. So we find a solution that would solve users' problems. So first we have to define what are the users and what are their problems. So possibly we would have to go out. There are very few occasions that we can do it in our own home. We could go to our friends, to our family, on the streets, talking to people, asking them questions if they really do have such problems as we think they are. And let's say after some time we found that health-aware people, let's say fit people or something like this, have the problems of expensive professional dietitians and too generic recipes available on the internet. This is actually true, so, you know, copyrights. But let's say it's the outcome. So first we have the problem and we have the clients. Then we have to go to the second stage where we defined our unique value that we want to generate to the users. So after a brainstorming, let's say we came up with an idea of Google for personalized diet recipes, which is cheap, instant. You can do it without leaving your home, and it's totally personalized to your own health goals. The next step is to find out a solution. We could also do it by brainstorming. We could look at the things that people said to us about their problems. And let's say we decided to create a web-based tool which takes as an input users' health parameters like height or his weight, target weight, something like this, and it outputs him or her the list of recipes for each day for the next, let's say, a month or so. So here, what we get is a problem-solution hypothesis. We think that these are true, that by this solution we will solve these problems of these clients and give them by giving them the value here in the middle. So now we move to the next step when we have to test the hypothesis. So we create the MVP. And how do you think, what features do we have to implement? What do we have to implement to make it work, to test this hypothesis? For sure, we will have to have some kind of user experience, right? So we have to have some kind of input box, search form, for example, when the users are able to fill their parameters. For sure, we will have to have some kind of list with the resulted recipes. And probably these two are quite easy to do, right? Because it's very basic web application. Probably you could do it in one evening. But how to make the recipes be right? How to make them to be really personalized as we want to be? We can either create the algorithm, which would probably involve some kind of machine learning, training the neural network or something like this. And it seems like this part is the most cumbersome one. This will take a lot of effort to do, and we don't even know if the users really need this functionality. So actually there is a way to doing this without implementing the whole algorithm, and it's called, there are two ways, and they are called Concierge Test and Wizard of Oz Test. Both of them involve sitting behind the wheel. So we don't implement the algorithm, it's us who will be giving the recipes, who will select the recipes for the users. And it may seem odd, but in fact it's a very common practice. It's used by multiple startups all around the world. And the thing is that you can use the concierge test, which means that the users know that it's you who deliver them the recipes, or you can use the Wizard of Oz test, where the user doesn't know, it's hidden from them. They think that it's done by the algorithm, or they don't think at all, but in fact it's you who select the results. And the first one, concierge test, when the people know you are there, it's good for because of the interaction you have with the users. It's good to get some more insight of your idea, because not only you give them the recipes, you provide them with the results, but also you can ask them questions. Typically the concierge test is realized by implementing some kind of chat box or something like this. So you could imagine that in our example of Diet Finder, the users would fill out the search form, click search, and there would be a loading pop-up with the information that the system is waiting for assistance, and after a while the users would get some kind of chat box with all the recipes and the possibility to interact with us. The second Wizard of Oz test is far better in terms of accuracy, because we test directly our hypothesis, our product, but without the cumbersome mechanism, the complex mechanism. When you create an MVP and you test it, it's always good to do interviews. So you go to your clients eye to eye and you show them the application and just observe. It's very important not to touch anything, not to help them, not to do anything. If they are stuck, if they, throwing the bad words and everything, it's good. It's for you, it's very good feedback, because you can improve your MVP. So after a while, when you receive the feedback and you provide the necessary changes, you can get a product market fit, which means that your product really solves the problems and produce the value for the users. But when you release the product to the public, it's really important to keep in mind that it becomes a business entity of one or another form. So it behaves in a certain way. And these, what you can see on the screen, are the elements of every startup. This model was created by Ash Mayura on top of Osterwalder's business model. And basically, when you put your hypothesis here, you can be sure that you don't miss anything. It's really, really useful in terms of creating a startup. So every startup consists of clients and their problems. It's our first column on the right in the previous previous slide. There is the value proposition, the solution. There is an unfair advantage, something that differentiates us from alternatives, because you always have to look for alternatives for competition. You always have the channels. So because you have the product and you give the product to the public, so there's always some kind of a channel in between. There are key metrics which you use to validate if your hypothesis is right or wrong. and the foundation of every business entity, which is revenue stream and cost structure. So if we put our diet finder into the model, we would get the product solution, value proposition, and clients' problems as we had before. But then we would go with the channels. So let's say we came up with the idea to give the product to the public by Facebook page and AdWords. This is only an example, so yeah. Our unfair advantage, and it's totally made up, can be basically anything that differentiates us from alternatives. Here, let's say we have a guy in WHO who is quite important there and can give us recommendation that we can put on our website. Then we have the revenue streams. For instance, it could be premium subscriptions. Let's say in the free ones you get just 3 days of personalized diet recipes, and if you pay some money, you get premium subscriptions for a whole month. It's also just an example. And then we have the cost structure. Here we would probably put development costs, infrastructure costs, advertisement costs. We would have to break it down to smaller parts. And the key metrics. It's something that we observe, and before the test we have to say that, for example, if our number of new users doesn't hit 1,000 within the first month, then our hypotheses are wrong. The metrics could also be something like new users per premium subscriptions ratio. And it's something called a cohort, and it means that not only you look at the value itself, because it can be misguided, but you use a metric that is related to some other metrics to get relation. Okay, so that's all in terms of the broad theory. Let's get some practical examples. So when building an MVP, you always prototype. It's all about prototyping. The MVP itself is a kind of prototype. All the features that we include are probably prototype features. So in such circumstances, especially when you want to do it as quickly, as cheaply as possible, it's paramount to leverage the third-party solutions available out there. And it doesn't really. It's not really important if you use something that is alpha or beta, or even if it's legacy framework that just has been deprecated. When prototyping, you can use basically anything that will allow you to deliver the MVP as soon as possible. And this is because when your MVP proves your hypothesis to be wrong, then you will probably have to throw it away, or at least modify it very deeply. So you'll have to invest a lot of time anyway. And if your MVP proves to your hypothesis to be right, then all the activities related to refactor it or even rewrite it are well allocated, because you work on something that you proved that is really valuable, that you will profit from in the future. The only exception from this rule is when the MVP cannot be done in a cheap and easy form. When you have to invest in the MVP a lot of money, a lot of time, then it's probably worth thinking about what you use. Maybe it's better to use some other tool which is stable, because it will save you more time if your MVP proves your hypothesis to be right. But this is the only exception, and actually this should be a very rare case, because your paramount objective in building an MVP is to do it as simple as possible, because if you introduce more complexity in it, you can impact your tests, your validation of your hypothesis. When prototyping, you often get into the point where you have a lot of snippets written in different languages. Because, for example, you create some fancy machine learning algorithm in Python because of the scikit library, which is very cool, very useful, and there's nothing like this in Java or C++. You could have your backend written in Java because of Spring, obviously, and you end up with a lot of code written in different ecosystems. And when prototyping, for sure, you don't want to rewrite it to the one stack just because you have something written in one language or another. So then you can leverage something, a new invention of Oracle, which is called GraalVM. It provides an additional middle layer built on top of JVM, which enables interpreters from different languages to communicate with JVM itself and interoperate between each other. It's a really cool tool. I really encourage you to get familiar with it. It provides you out-of-the-box interoperability with any supported languages, which currently are Java, JavaScript, Python, Ruby, LLVM, which gives you ability to interoperate with C or C++ even. It gets support for R, Rust, Ruby, and even MySQL and database, which is, for me, it's really cool. So here's an example. I hope it's. Can you see it? No. Not really. Okay. So here's the example. It's a very easy one. We have the context object of polyglot library, and you can evaluate scripts in different languages. So here we evaluate hello world from JavaScript, from Ruby, R, and Python. And when you run it, you can see that the outcome is visible on the console. But it gets really interesting when we leverage the interoperability. Here we can see the part of a main class. We created a Java record, a totally custom-made class. We created the context, and what we did here is we put the record, the created record in Java, we put it to JavaScript interpreter, where we can use it as it was created there. So it's like with no additional overhead, we get interoperability between those two languages. And then we assign a value to a parameter, and as you can see here, we use it back in Java. And here we can also invoke functions. Basically, we can do anything we could do if the object was created on stack that we use. So another example of a useful tool when prototyping is the serverless architecture. I'm sure many of you are already familiar with the concept. It's very popular recently. So basically what it does, it cuts the necessity to create the whole architecture yourself. So basically you just create a client side which connects to serverless architecture provided by the serverless provider. We have a lot of providers to choose from. We have Google, we have Amazon Web Services, IBM, Azure, Kubernetes. So there are a lot of them to choose from. Sorry. So from the high level, serverless architecture works like this. We have configuration done on the provider side, where we define events that will trigger our functions, which can leverage services available in the provider. And the functions, the serverless architectures address similar problems that GraalVM. So we can write the functions in different languages, in different stacks, and not worry about their interoperability. So the events can be either HTTP requests or some other requests. They can be changes in the database state. So we can trigger some functions with changed files or with changed data model state, and the change invokes a function, and it produces some kind of a response. So for us, it means that we create only the client side, and the client doesn't connect to our server, but it just invokes some functions on the provider side. So here we have a real simple example of a handler provided by AWS, Amazon Web Services. So as you can see, all the magic is about implementing the handler, and here the handler will respond with current time. It will also add a few headers to the response, and it will build the response with status code 200 and return it to the provider. Here's a snippet of the configuration. So we have our main service, which provider is the Amazon Web Services. We define the runtime. We also define the package that we want to upload to the provider. And as you can see, it's just a simple jar, so we can use Maven. There's no magic here. We use the same build system as with any other application. Here we also define the functions. So as you can see, there is the event of HTTP request that binds to get method on path ping, and it causes the handler to be invoked. So the previously implemented handler will be invoked when the provider architecture receives get ping HTTP request. When we deploy the function to the server, we get something like this. It doesn't really necessary to dive into it. And after the function is deployed, you can send the request and see that there is a response. We can also leverage an invoke command from serverless to dive into the details of the response got by the server. So it's very good for debugging our application. Here you can see that we use the serverless as CLI tool. Serverless is let's say one higher level of abstraction on top of the provided of the provider's library. It makes you easier to deploy your functions on different architectures like Azure, Amazon Web Services, and so on and so forth. So to wrap it up, I wanted you to know that in terms of startups, they behave, when you create a startup, you basically can follow the same rules as you do when you code, when you test your code. So first you have the hypothesis, you have the basic implementation, which doesn't really solve your problem. It makes your test be red. Then you implement it, you implement the startup, you check if your test made beforehand really passes or fails. And when it passes, it's the time to refactor your code. So then's the time to adjust all your startup components to make it look really well and to be cool. And then you go back to stage number 1. So then you want to develop your startup even further, and you have to follow the same rules. So first you think of the changes, you create a test for them, you test the hypothesis. If it's wrong, you have to go back. If it's right, you can follow and refactor it to the way it looks good. So that's everything from me. You can always find me on Facebook, on LinkedIn. If you want to talk about startups, I would be really keen on talking with you after the presentation. So thank you very much.